Hi all, it's Sammy here from Avid CNC, and I'm excited to be back doing these live streams again. Hopefully we'll get to keep them up pretty regularly, and I'm excited to share this project with you today. If you're tuning in live, let us know where you're tuning in from, and if you're working on any projects in the shop right now. Let me know if you have been using Fusion, or if you're interested in using Fusion 360, and what might influence whether or not you try that out. I really think that picking the right CAD and CAM program for the specific type of project you're doing is really important. There's so many different options and they all have their strengths and weaknesses. But this is a really introductory level for Fusion 360. So what I like about this project and what I kind of just tried to design it around was the concept of just having one piece of material. It was something that was going to be useful right out of the gate. As soon as you took off of the CNC bed, you can customize it for your shop needs and that sort of thing. So sounds good. I'm just going to check out the chat over here. Okay. Hi everyone, thanks for tuning in. It's good to see all the regulars. I really appreciate y'all being here. And Olivia, I'm excited to see that teardrop build. One of my dreams is to build a teardrop trailer, but put a Benchtop Pro in the back of it so I can bring it to, in the future when we're able to do this again, do meetups and maker fairs and that sort of thing. So get those cogs going on brainstorming for that. Puerto Rico, Canada, Kentucky, hey everybody. Okay, so I'm going to bring up my live stream question. It's here. Awesome. Okay, so first of all, let me just show you what we're making, and then we'll jump into the Fusion tutorial, and then I'll show you how to set up and cut the part, which I did yesterday. So that's Sammy from yesterday that'll show you how to do that. So let's check out the project. Okay, so let me know too if the sound is good, and we did some tests early, so hopefully it sounds good. Here is the tool tray. I had some scrap bamboo plywood. It's super simple, just 2D pockets. I can put my collets, my wrenches, different router bit selections. I just made a simple tray here for my V-bits, X-Acto pencil. One little neat feature about the sections that hold the router bits is I made a secondary smaller pocket towards the front, and when you press it down, it lifts up. So it's much easier to pick up than a previous design I had. And I stole that idea from Alex Chappelle, I believe. He's a really amazing designer and content creator, so you should check out his channel as well. So here is this tray. Here's another tray I've been just kind of using just because it was around. I made a bunch of these out of scrap years ago. This was just like leftover mahogany from, I don't know, another project, which you can see is just full of random screws and blades and Allen keys and router bits. And there's a nice, section that could hold my touch plate, which I didn't include in this particular design. But you can customize it to fit whatever your needs are. We did another project a few years ago that was a tool tray that had handles, which I think is useful, but in this, not as necessary. I think keeping it simple is better, especially for our first project. So this is what we're making. Okay. Okay, sound is good. Awesome. Oh, awesome. So we got San Diego, and it's cold and wet in Illinois. I'm sorry about that, bud. The 4 horsepower router is amazing. Oh yeah, this little spindle packs a punch, and it's really I've really enjoyed using it. Hi, Christopher. Thanks for tuning in. Okay, so we're just going to go ahead and jump into Fusion. I have, what we're going to walk through is the design workspace and the manufacturing workspace. We're going to keep it very simple and just on introductory tools here. We'll go deeper into it in the future. I've also linked some tutorials from Kevin Kennedy from Product Design Online. He makes really amazing Fusion specific tutorials, and I highly recommend checking out his channel if you want to dive deeper into that sort of thing. He's got a great introductory to Fusion 360 for woodworkers class, and it's a really great resource. So I've tried to link a bunch of resources in the description. So here is what the design looks like. Here is what the design in the CAM workspace looks like after I've programmed the toolpaths. So let's just go ahead and start with a blank design. So I have a design that hasn't even been saved yet. You can click on this plus button here to create a new design. And the first thing you'll do is go ahead and save your design. We'll do File, Save. And Fusion is cloud-based, but you do have to save it at least once, you know, and try to save periodically so that it's definitely backed up and you are ensuring that your files are saved properly. So let's call this Tool Tray Livestream Example, right? And we'll save that. So now I have a new design here to work with. And Fusion 360 is a sketch-driven design software. So any changes I make in my sketches will alter and change the dimensions and shape and form of my 3D model. So the first thing we're going to do is going to create a sketch. So I'll go up here to my Create a Sketch icon. If you hover over a button, it'll pop up with this gray box with pictures and explanations. You can always Control plus slash for more help, and if you happen to be a subscriber to Fusion, I believe there's the in-chat feature as well from the support team. So I can select any of these planes to place my sketch. So I can select the this is the YZ, this is the XZ, and then the XY. So that's what I'll select here. And we'll close our window, the data panel on the left, just so we can kind of focus in on our design. And I'll just move my camera here so you can see my timeline a little bit better here, okay? Awesome. So we have opened a new sketch, and up here we have our vector that we can use to create those drawings. It's just like any other 2D drawing program. So you can click line, rectangle, center diameter circle. Splines are really lovely too. I've added a few up here that I like to access fairly often. So mirror, I like to use fairly often. I've also added change parameters, which is kind of more of a deep dive to use later on if you really get into it. But we're just going to focus on just entering in the dimensions that we know. So we'll do create, rectangle, and I'll do center rectangle. So one really great tip I learned from Karenna Harper, she works on the Fusion 360 support team and is just an incredible designer, is one habit I used to have when I would model using different programs. I would always model over here in this kind of positive workspace in terms of the Cartesian coordinates. But one tip she would say is to model from the center out. So utilize all of this space. So I'll model from the center outward. And here you can see I can go ahead and click and place my rectangle, or I can go ahead and type in the dimensions. So I'll make this 6 inches and then tab to my other dimension and type in 18. and then click to confirm. If I go up to select, it'll take me out of my rectangle creation mode, and I can double click on the dimensions to change those. If I had not defined a dimension here, if I delete this, if I click the letter D as my hotkey, select an edge and pull it out, I can change this dimension. So I can type in 7, or I can type in 6 and change it back. Okay, great. So we have a rectangle. Super. I'm going to click Finish Sketch. So now here is my design that I'm working with. Now I want to extrude this shape because I have the boundary of what I want to work with. And then I will go to Create, Extrude. There's also this quick key right here, or if you just hit E on your keyboard, that also brings you to Extrude. So there's a couple different ways we can tell the program how far we'd like it to go. First, you can just pull this arrow up and down, and it'll just snap to your grid. You can type here, I would like this to be 1 inch, or in the window on the right, we can type in 0.75 inches if that's the material thickness that you're working with. You can also add tapers. You can tell it, do I want to pull in multiple directions or just one side? We'll say one side for now because we're just cutting one piece of plywood here. So we'll say okay. Great, so now I have my kind of the form of the tray, the final shape of the tray. So now I want to create another sketch. We'll go to Create, Sketch, and then we'll select the top of our block. So I don't have to only select the origin planes that were provided. I can now select the surface of our material as well. So now I'm drawing on the top of our material. Okay, here I will now go ahead and just start drawing a few more rectangles and shapes that I'd like to recess and pocket for my tools. So this would be an ideal time to take your wrenches out and your calipers and just figure out exactly how large you want all of your pockets and dimensions to be. So I will go ahead and click and drag this box, and we'll just make a couple of just estimates here. I'll do D for dimension. One thing I do know I want is a nice border around the whole edge of my tray. So if I click D, let me redo that again to show you. If I hit D, the hotkey, and select the top edge of my rectangle and then the top edge of my tray, come over here, I now can set the distance between those two lines. So I will type in 1/2 inch, and I'll repeat that for the edge as well, the left side. Great, so now I have my dimensions for the pocket for the wrenches set. Now I want to create a couple for, say, my 1/2 inch router bits. So if my router bits are a little bit taller than, I have some that are, let's see, these ones are 4.5 inches, so I like to make the pockets a little bit taller than that. So when there is the radius of the router bit making the pocket, the flat edge corner of the router bit won't be limited by the radius of the pocket made by the router bit. And I'll show you what I mean by that in a minute, but we'll just make them a little bit taller so they can nest well, but not so that they roll around or anything like that. So we'll do 4.75 inches. Tab to do the other dimension. And we'll do 0.55, just so it's a little bit wider than we need. You can keep repeating this process and typing in the dimensions if you'd like to do it this way. You can also create a rectangle here. let's say this is for the 1/4 inch bit, and we'll call this 2.75 inches tall by 0.25. We'll make this 2.7 inches, or make this 0.3 inches wide, just so it has a little bit extra room. So we have a few rectangles here drawn, pockets, but we want to, it's a little bit cumbersome to keep drawing a bunch of them in a row. So let's create a pattern. So I'll go to Create and go down to Rectangular Pattern. And now it's prompting me to do a few different steps here. So one great way to work in Fusion is to, when you're given a pop-up and you're still learning the terms and that sort of thing, if you hover over something, it'll explain to you the different parts of what it means by that. First we'll do select our objects. So I just want to select the edges of this rectangle here. And then the direction, it's wondering which direction do I want to pattern this shape in. So I can pull the arrows, and I think that's the simplest way to do this. Here it's giving me some opportunities to enter in those dimensions and the quantity. It asks how many do I want? I'll do, let's say 6 here. And I can just continue to use the arrow to determine the spacing. I can also type it in there as well. You can pull in multiple directions if you like, but let's just do one direction and click OK. So now I have my set of the 1/4 inch bits, and I have my 1/2 inch bits as well. We can set these dimensions so those are even with our border. So you can see how this is a fairly straightforward way of drawing in Fusion. And then we'll make the spacing between those two bits. I see. Great. So you can kind of space those out however you prefer to do that. I just want to say hi to everyone over here. Any recommendations for CAM intermediate with Fusion specific for woodworking? There's definitely a lot of folks who work with presenting Fusion projects that are, for an intermediate level. We had a project I did maybe a year ago or so. It was a parametric bookshelf, and I think that was a really great intermediate project for Fusion 360. And maybe Brian can try to track that down for you. He's in the chat with us today. Thanks, Brian, for joining us. I really appreciate it, being here with us. Okay, so now I can go ahead and continue to add additional features. We can go to, let's make the collet dimensions. I believe this was 1.375 inches. Oh, my keyboard is not switching. 1.375. And let's just go and check. I'll just go check my my other drawing really quick here. So if I go down to Design, Sketches. Oh, that was the original sketch for the surface. And here I can check out all of the dimensions I created for the one that was cut. This was 1.375. So that fit perfectly for the collet that, this is the ER20 collet and nut combination. So I'll go ahead and set this dimension. I wanted to show you how to do a very simple formula in setting dimensions in Fusion. So when I am going to set the dimension here between the edge and the edge of this circle, it actually kind of just snaps to the center of the circle. So I can't necessarily type in 0.5 inches because it's not the distance between the edge of the tray and the edge of the circle. It's between the distance between the edge of the tray and the center of the circle. So here we're given an opportunity to type in that dimension. What I would do here is determine what is the radius of the circle. It's 1.375 inches is the diameter. That's not exactly, as easy as if it was 1 inch. So doing it in your head isn't something you necessarily want to have to do. So we'll type in parentheses 1.375 inches /2. So it's divided by 2, right? So that's the radius, plus 0.5 inches. So you can type in these formulas and enter in these parameters. I'm actually going to copy that, Control C, and then click Enter. And now you can see that this circle edge is pretty much parallel tangent with this edge of the pocket there. So I'm going to do the same thing between the bottom edge and the center of the circle, and I'll Control Paste and Enter. And so now you can see it's offset about 1/2 inch from the edge there. Now our pocket above is a little bit too tall, so I'll just click on the edge there, pull the dimension out, and change that to something that fits a little bit nicer. I can make it 3 inches or 3.125 maybe. So something that just nests in really well. It can be aesthetic or it can be, really practical depending on what you need. We want to make a few more of these collet holders. So we'll go ahead and create a pattern again. So I'll go to Create Rectangular Pattern and just place a few along the way here. Let's see. I feel like that looks nice. We'll say OK. So the nice thing is that this doesn't have to be super precise in the spacing between. You just want to make sure that everything is going to fit in those shapes that you're making. We will reset this drawing to look from the top view. It's a little bit easier to draw that way. And I will just create a few more shapes here. You can make a really long one like this maybe for pencils, or you can make separated individual trays. And we'll just go ahead and set these dimensions as well. It's not letting me snap there. Okay. There we go. 1/2 inch, right? Okay, I feel like this, looks pretty satisfactory to me in general for the overall layout. You can obviously change and make this exactly how you like. So now I'll go in, and there's one other thing I'd like to do, and that is the feature in which you can press down on the bottom of the router bit shank, and so that the top of it will pop up so you can easily lift it up and out of the tool tray. So I'm just going to create a few lines here. Maybe I'll do it on this one like this. So I just drew a line from one side to the other, and I'll do this on the 1/2 inch bit as well. And I want to set a dimension from the bottom of this rectangle to the bottom of this line. Let's say 0.75 inches. Okay. Maybe these ones a little bit taller, 1 inch. Maybe 1.5. I found that you didn't want them to be too tall, otherwise they would kind of teeter into that area, but it was really helpful if they were just about 1/4 to 1/3 of the overall shank length, in order to kind of optimally let them lift up. So we will pattern this one line, and then we'll get into actually extruding these pockets. So we'll create a rectangular pattern. I'm just going to select this vector here and change the quantity to 6 and offset them 3 inches because that was the same as the offset or the spacing we made for the 1/4 inch router bits here. Let's say okay. Great, so we have our tool tray vectors designed, and I will just click Finish Sketch. So as you can see, we just have our sketch that's sitting right on top of our extruded base of our form here. So we'll go to Extrude again, and all I have to do is select these sections in our design and either pull up or push down to cut into our shape. You want to make sure you're not going to cut too far down into your part, making sure that there's a little bit of thickness on the bottom of the tray. I'd say for these sections, 1/2 inch seems good to me. We can look over here and check out what is it's prompting us to do. We'll extrude on one side. The extent type is the distance. So we just typed in the distance here, which is a -1/2 inch. You can add a taper angle to it if you like. I'm just going to keep it as a straight wall. And you can create a cut, or you can join. So say you're making a new shape, but you want it to fuse to a shape that exists already. Would be what you would use that for. You can create a new body or a new component. The differences between bodies and components, there's quite a few of them, but for now bodies are just fine. So if you're new to Fusion, learning about the differences between components and bodies is something to do a little bit of a deep dive into. Okay, we'll just do a cut operation here and say okay. So now you can see we have our little recessed areas. So one thing to note is that these corners will be radiused, and as I was kind of mentioning before, because of the router bit cutting from the top, the radius of the router bit is obviously going to leave that radius in the corner as well. So it hides the sketch after that first extrude, so we'll turn the sketch visibility back on, and I'll go ahead and extrude these pockets as well. Hit E for extrude, and I'll just go ahead and select these shapes. So for the 1/4 inch bit, let's make that minus 0.2 inches. Oh, there we go, minus 0.2 inches. That's minus, I have two minus signs there. Okay, minus 0.2 inches. So we're subtracting that shape from our body. We'll click OK. Awesome. So right now it's just a completely flat pocket. So what we'll do is extrude again, but we'll select just the bottom rectangles, and we'll bring this down. Let's say 0.4 is probably fine here. So we'll cut that distance down. And so now you can see it's kind of got a step down there. So this is where, hide the sketch for a second. So this is where the tool will sit for most of the time, but when you press down on the bottom of it, it will come down and touch this surface and be able to kind of pop a wheelie, you know what I mean? Okay, so we'll do the same for the 1/2 inch bit. We'll extrude. Maybe 0.4 inches is good. Say okay. Extrude these two surfaces. We'll do let's do I don't know, 0.6 would be good, I think. Okay, and say okay. Great, so now our 1/2 inch bits have their little resting area as well. So you saw that I didn't pocket these all the way down for the full height of the diameter of the bit. You can sit them below the surface of the material. I don't think it's really necessary. You just don't want them to roll off the tray, and this is plenty to keep them in. So you can see we have sharp edges here. There's a couple ways you can change this. You can change and add fillets in the sketch. You can add fillets here in the 3D workspace just by clicking on these edges and adding a fillet. So if we were to go look at the sketch and edit that, we'll go to Modify, Add Fillet, and you can click on the corners here, and this will be able to just add a little radius to the corners as well. So you can click on the corners or the two edges that meet to form that corner. You can type in 0.125 is the radius of the bit. And if you click enter, it will change the shape here of that rectangle. If we say finish sketch, if I zoom back in, you can see because I altered the sketch, it altered the model. If we look down here on the timeline, we can see that the sketch was created prior to these extrusions being made, which was the subtractive element of making the pockets for those router bits. So because that extrusion was made based on that sketch, any changes to the sketch will change the extrusions that we have created as well. You don't necessarily need to add all of these fillets for it to show up in the CAM, because the limitation of the router bit will automatically kind of show up in your cut anyway. So in my tray, I have rounded corners, even though I didn't necessarily take the time to go and put fillets on all of my corners. Okay. Let me just look at these questions really quick. Can you discuss later how to manage tool changes within Fusion? Okay, so like manual tool changes really rely on the tool numbering system. I have been making, we have a video coming out really soon for how to perform manual tool changes in Mach4, and making sure that your tool numbering system is working is really the most important thing for doing manual tool changes. Okay, great. So we have our design created, and now we can hide our sketch. And if you like to, at this point, I like to give an appearance. So if you hit A on your keyboard, you'll be able to add a new material to this. So I will just put, since I'm using bamboo plywood, I can go ahead and click and drag that, or you can add, I don't know, ash or something here. If you double click on it, you can kind of change the colors of it. If this is really great if you're making something to show a client and that sort of thing. Okay, super. So here is our tray. And now we're going to jump into the manufacturing workspace. We'll go to design. Here's the render workspace if you want to make a nice render of it. We'll go to manufacturing workspace. And here is where we're going to set up our toolpaths and that sort of thing. We're going to keep this really simple. I know you're interested in learning in how to do the tool changes in Fusion, but we're just going to keep this with one router bit selection for this project, just because it's that simple. I only really need a 1/4 inch tool. So we'll go, here is setups. We need to create one setup for our project. One thing I really like to do, and this is a personal preference, it really depends on the kind of project you're doing. I'm actually going to take us back to the design workspace really quick. I really like to model my material and just have that be a shape I can reference when making my manufacturing setup. So we'll go to create a sketch again, and I want to select, we're going to hide the tool tray for a second, and I want to select the same origin plane, the XY plane. I'll create a rectangle and do the center point rectangle again. At this point, you want to take a measuring tape and measure your material. I believe my material was somewhere around 8 inches by, 8 inches tall by 22 inches wide. Okay, so this is about the size of my material. We'll say finish sketch. And another really good habit I would hope you can pick up is naming all of your layers and sketches. It's a really great habit, especially when things get really layered. So I'll go ahead and extrude this shape and make it the same thickness as my material, so 0.75 inches, and click OK. If I turn the shape of my model on, I can't really see it too well. So one thing I like to do is to apply some sort of a transparent appearance to the material. So I'll just I usually use glass for some reason because it's a nice, kind of a nice color. And I'll click and drag that onto my material. So now I can kind of see where the tray is within that material, kind of like the, you know, Michelangelo's, like where the sculpture is inside there. I just have to know exactly where it is and how to reveal it. So we'll go back to the manufacturing workspace. We'll go up to Setup here and New Setup. So this is where we're going to initially start out with our telling Fusion exactly what the model is that we're focusing on cutting, and then what model we're going to reference as our stock. So before I even get into this, I like to go to the Stock tab, and it says relative size box. So it tries to make a shape that's relatively the same size as your model. But I like to go down to From a Solid. And in my models, I will select the body 2, which is my material I've modeled. So now that has been selected as being my stock material. We'll go back to Setup. And at this point, I will hide the model of my material because it's now being referenced, but I don't need it to be in the way for me to select other things. So for machine, we can skip that for now. This is kind of becoming a newer feature in Fusion, and hopefully we'll be able to be a part of that really soon and have our machine models available, you know, kind of for preview and that sort of thing when you're running your simulations. We're going to say our operation type is milling. And this is our work coordinate system. So this is a little bit different than in VCarve, you know, it's just called the work coordinate system. It's your 0 essentially. So where is our G54 offset or whatever you're using, if you're using G55, that sort of thing. It usually defaults here to the center and the top of your shape. I like to select the box point, and I'm going to select the front left and top surface of my material. You can always select the bottom corner, which is the surface of the spoil board. But I think this is the easiest place to zero when especially when you're starting out. I don't think there's a reason to not select that other than if you don't really want to cut into your spoil board or something like that. This is if you already know the thickness of your material, there's not going to be this is just the best way to not make as many mistakes, you know, because if you accidentally zero to your spoil board, it will. Okay, so let me back up here for a second. So there's a lot of different ways and reasons you might pick a different zeroing position. I think that this is the easiest when you're starting out. If you just keep that as a standard to start out and then make changes, it works. You're a lot less likely to make those mistakes. But essentially, no matter what you pick, make sure that you're double checking exactly what you set up in your CAM program as you are setting up on the machine. And that's the most important thing, is that those two things align. So we have our 0 selected, and then we can go look at the post processor here. This is just the name and the number. So we're just going to leave everything, simple like this and click OK. You can change the name of the program though if you like. Oh, I didn't select my model. So let me open that setup again. So if you go back to setup here, I skipped select the model. And we'll select that shape there because it defaulted back to the stock material, which I had selected. So we have the body selected. Now click OK. Great. So now we can actually machine our component that we've made, or our body. Super. So we're just going to make 2 simple toolpaths, and that's going to be a 2D pocket and a 2D contour. So I'll go to 2D pocket, and this is going to bring up our options over here. Sometimes it opens like this, but if you pull it out this way, you can see the names of each of these tabs. So the first thing we'll do is select our tool. And I have a router bit here selected already that I've made. It's a 1/4 inch, a down spiral bit, and I already have all these settings already applied. So once I select that, it will change all the settings here in the feeds and speeds options. 18,000 RPM is our spindle speed. I have a lead in, lead out, and cutting feed rate of about 300 inches per minute. The ramp and the plunge is slowed down there a little bit. And we'll go to our geometry. And here we want to select the surfaces that we'd like to cut. So I will go ahead and just select the surfaces. You can select the edges here, but I just prefer to select the faces. I feel like that is the simplest way to select those shapes. If you hover over it, you can see which surface you are about to select. Okay. So you can see all these are on different heights, and that's okay. So if we go to heights now, this is all the different heights that the router bit will lift up to and move down to throughout the operation. So most of these we would like to leave as it is, except for the bottom height. We want to make sure it says the selected contours. So those are, we'll say selection, yeah, selected contours that we have for the cutting operation. That way it will cut to each surface that is selected. The top height is the stock top. And if you hover over these, it'll give you all the definitions and the different heights of those, the settings. If we go to passes here, I want to make sure to turn on multiple depths. That way it'll do multiple step downs. If we go into this section right here, you can right click and you can either type in the dimension that you'd like the step down to be, or you can say edit expression. Here I've set it to be tool step down. So if I just type tool, it will give me some options that it can reference. So the step down I selected as going to reference the step down that we have entered in our tool library. So I'll just select that and say OK. I'm going to turn off stock to leave. I don't necessarily need that to be on there. Here we can enter in the finishing step down if you want it to be a super clean bottom surface layer, or if you want it to be even step downs, but we're just going to leave it the way it is just to keep it simple. And then we'll click OK. And here now it will generate our toolpath. So if we go up to simulate, here we can simulate our toolpath cutting. And here's the speed at which you can increase the preview. Super, so that looks like a nice, simple operation to me. And now let's go ahead and program our contour. We'll go to 2D contour. You can also select it here. That's a very common one, so it's already up in the toolbar. And you can see it's already automatically defaulted to the tool that we had selected in the last toolpath. So I'll go to geometry and select the bottom vector here for my tray, because I just would like to cut the tray out of the out of my material. Okay, so this is 2D adaptive. Okay, so I clicked the wrong icon. I wanted 2D contour. I saw that the tabs option was not available. I was accidentally doing adaptive. So let's do 2D contour. The tool has been selected. We'll go to geometry and select the correct contour. There we go. And so now you can see that tabs is available. When you're placing tabs, this is, it really depends on the material that you're using. I like to be fairly conservative, but I don't want to spend too much time cleaning up tabs. So we'll make them triangular, because if you're cutting out of a hardwood or really good quality plywood, you don't necessarily need to use really thick rectangular tabs, because the plywood will be pretty strong. So let's make them I like to make them about 0.3 inches if it's a good quality wood. If it's going to be a shop ply, you might have more voids in your material, which means that it's more likely that your tab is not going to be as strong. It might break out while you're cutting it. So we'll go to at points instead of by distance, and then here I can just place my tabs like this. Okay, and so then the heights, we're going to leave the same. It's going to cut through to the selected contour. You could also, for this one, because you'd like to cut it all the way through, you can say model bottom, so you can cut all the way through the material. The different passes, I'd like this to be multiple depths, and say okay. And so now you can see this has been, we can watch this in the simulation. And so if we hover over it, we can zoom in and see how the toolpath lifts up for the tab there. Super. So this is how you create some very simple toolpaths in Fusion. Next, I'd go on to post-processing. So if we go to Actions and Post-Process, here is where you save out your toolpath. You can change the name or number of your program. Here is the location of the output folder. So this is where you're going to be saving your G code. So let's go ahead and save this code together. So I have, this is the post I'm referring to. If you want the updated Fusion 360 post for Avid CNC, I will make sure to add that in the description for you to reference. Here's some options that you can turn on and off. If you are using a dust collector that is a relay or something like that, here are your options to turn these on and off. Okay, so use M6, that would be right for your tool change. Okay, but we only are using one bit. So we'll say post. And here is where we can save our program. So I can also rename it here, tool, tray, G code. And I also like to put little notes in here, 0.25 down spiral, 0 material, front, left. So that's just a nice reminder for me, or if there's a certain file naming convention that works for you, please let us know, share what your methods are. And so then you click Save. So awesome. This is kind kind of the end of the fusion part of the tutorial. We're going to jump back into the past and do the walkthrough for how to set up the project and cut it on your CNC machine. And I will be back at the end to answer some more of your questions, or I can answer them in the chat as well. Oh, I see. I have a question here. Placing the 0 on the top of the material is implying your stock must be perfectly flat. I'm guessing a surface is needed or not. Right, so as Brian was mentioning, you can include a surfacing toolpath. If you have a rough surface, so I actually have a really good example of this. I have way too many random scraps of material around. Actually, this one's rough on both sides, but let me switch to. So here I have like a really rough piece of material. In this case, in order to be really repeatable, zeroing to the bed makes way more sense. I think that just starting out, if you, when you're setting up your tool, your 0 on the machine, if you are just defaulting to zeroing to the surface, then if you accidentally zeroed to the spoil board or the bottom of the model in your program, it'll do air passes, which is kind of the lesser of kind of the things that could go wrong there. But you're right, it depends on what distance you value. And we did a zeroing live stream about this. And I kind of talk about the theories of this, which I could talk about for literally hours. So let's circle back to that, and it's a really good point. We're going to jump into the past and do that walkthrough, and I'll be back to answer some more questions. Okay. Hi everyone, and welcome to the next portion, which is we're going to set up our material on the CNC machine, open up Mach4, get our machine set up, and run our program. So let's go ahead and jump into it. First thing I'm going to do is get my material here. I have the bamboo plywood all cut, ready to go. It's a little bit oversized from my final part, which is great because I have a lot of extra work area. Go ahead and put it on my bed and consider what kind of work holding solution I want to use. So you can use whatever is your preferred method. There's always going to be pros and cons. We have a whole playlist dedicated to this, and I'll link it to the description below. You could use blue tape, double-sided tape. You could use clamping fixtures, screws, or metal fasteners. I'm going to be using a composite nail, which I have this special Omer Nail Gun, and if you don't have one of these, or if you've never used one before, I highly recommend considering them because it is such a quick and easy workpiece setup, and it will really save you a lot of time in the end. So let me show you how it works. So I'm going to go ahead and set up my material here on the bed. I like to have a variety of different ways to align my workpieces. Some V-grooves, some holes for dowel pins to go in so I can just push my material up against it. I'm just going to use the V lines here and just kind of roughly get that aligned. I don't think my material is perfectly straight, but that's okay because I'm cutting the shape out of this material. If I was going to do an engraving on something that was already cut to the final size, I would want to be far more particular about how it is oriented in relation to the spoil board, but I'm not so concerned about that right now. So let's go ahead and find our composite nail gun. So this is what I am using today. If I pull this trigger back here, I can get my composite nails here. So with the Omer Nail Gun, I will just insert the nails. Well, first I like to figure out what size is best for the thickness of the material I'm using. So I'll hold it up against here, and if there's about a 1/2 inch above the height. That's about how deep I'd like it to go into my spoil board. So I'll go ahead and insert the nails, release the trigger. Okay, so now is about the time where we'll put on our safety glasses. And we'll get our air hose here. All right, I have my Omer Nail Gun now connected to the air, and I'll just go ahead and put 4 spots here. Need a little bit more air in my air compressor, so let's go ahead and turn that on. So I went ahead and put in 4 composite nails, just 1 in each corner. I know that I am not cutting that close to the edge. Normally that also wouldn't matter. Composite nails are great because you can machine right through them without worrying about damaging your bit. They do sand and paint really well. I just don't want the composite nails to show up on my workpiece or my final product because this is bamboo plywood. It's already really beautiful, so I don't want it to show up there. If I was doing something like painted plywood cabinets or MDF, that wouldn't be as much of an issue. It is really nice because it gives you some peace of mind about whether or not you're going to hit your actual fasteners and damage your bit later on. Okay, so now I'm going to go ahead and turn on the controller for my CNC machine. So now you can probably hear the fan come on. I also like to put my hand near the fan if I'm in an especially loud shop, so I can tell whether or not the controller has turned on. You know, sometimes something comes unplugged, and that's a really easy way to tell if your controller is on in a loud shop. So now that I have my controller turned on, I want to ensure that the controller is connected to my computer. Here I have the Ethernet cable plugged into a USB adapter into my control computer. So the controller is on. Now I can open up Mach4 on my controller computer. And we'll let that open up. So if you haven't already updated Mach4 recently, I recommend going to do that. I've linked a description, I've linked a link to that below. Keeping Mach4 up to date, check once a quarter or so. It'll be really helpful so you can always get the next features that we add to Mach4. For example, the spindle warm-up program is one of those. Okay, so now that my controller is connected, I'm going to go ahead and click Enable. Oh, down here at the bottom it says eStop is in effect. Clear the eStop condition. So I won't let me enable it because the eStop is accidentally pressed. So, oh yeah. So you can see my eStop is right down here, which can be kind of nice because it's easy to access, but I'm just going to twist and release that. So now that my eStop is released, I'm going to go ahead and click Enable. So now that Mach4 is enabled, my CNC machine is on, it's connected. I can use the arrow keys on my keyboard to drive my machine around, right? Great, so now I'm going to go ahead and move the gantry forward so it's a little bit closer to the front of the machine. I don't want to move it all the way up, but just enough. Okay, great. So now I can home my CNC machine. So what that means is it's going to find the limits of its machine work envelope using these inductive proximity sensors. So the metal of the gantry will set off the front Y1 and Y2 sensors. There is an X sensor on the other side of the gantry. Here's the X plus, and then here's the Z plus. So this will rise up and detect the Z gantry plate. So we'll go ahead and click Home XYZ. Awesome. So this is a really important thing to do at the beginning of every time you turn your CNC machine on, because when your machine is turned off, the motors are not enabled, which allows the gantry or the motors to move around and become misaligned. So it's just so the machine can really wake up and kind of find where it is in space. So it will help with your repeatability, and I recommend that being a part of your startup routine. Okay, so now we're moving forward. We have our material attached. You can give it a little wiggle test here to make sure it's fully attached. We have homed our CNC machine. Now we can set our 0. So in our program, we want to always double check where our 0 is set for our workpiece offset. Go ahead and click OK on homing the machine. Great. So I will just use my arrow keys on my keyboard. To jog my spindle over to right about where I want to set my 0. I'll take my touch plate here and I'll use the corner finding edge to place it on the corner of my material. Kind of set up my cable so that it is, there we go, right? So it sits pretty comfortably. I'm going to attach, ideally you want to attach the magnet to the bit for best connection, but you can attach the collet, but this will create the circuit. So when the bit comes down, it'll touch the brass plate, come up and touch the top edge and then the inside edge here. So we'll go to our Auto Z and corner finding touch plate icon here, and it'll open up this window for us. So the first thing I want to do is to enter in the diameter of my tool, so 0.25 inches. If you're using millimeters, you can use millimeters. This is part of that algorithm, so it knows the exact dimensions of the touch plate. So when it comes and touches off the edge, it needs to know the diameter, or essentially needs to know the radius, so it can figure out the offset from the center of the spindle. So that's how that works. We have several options here. We're going to use the front left corner probe, and if you hover over it for a little bit, it'll give you a little bit more of that description. Before we do this, let's just double check that the probe will create that full circuit. So one way I can do that is to lift the touch plate up and touch the bit. So you can see on the screen it probably is turning blue. Yes. So up, down, right? It's connecting, turning on blue, which is a good sign that it's going to be able to complete the circuit. So now we'll go to do the touch off. So go ahead and click that button and it'll go ahead and automatically move down. Touch the brass plate, lift up. It's going to, in Mach4, request that we rotate the edge of the flute to touch the Y wall. We say OK. And we're going to rotate again to touch the interior X wall and click OK. Great, and now our touch plate probing is complete, so we can remove that. So we have now set our workpiece offset from our machine coordinates. So we can go ahead and now we can load our G-code. I'll close this window and we'll go to, under File Ops on the bottom, we'll click Load G-code. Here's where we can navigate to our G-code. So locate the file where your G-code file is saved, and we'll open up that file. Super, so here you can see we have our code loaded. We have tool 1, which is a diameter of 1/4 inch, which is good. It's a flat end mill. Okay, great, so that's what we have located. And then if you scroll down, you can just see the basic toolpath operations down here. Here is our preview window, which is really nice to look at. If you want to, you can always jog your spindle over, and you can see that the red crosshairs here are showing us where the toolpaths are located in relation to the material. So if we just jog around, that's a good way to make sure that you're going to stay on the material, that you've set up everything correctly. Great, I'm really happy with that setup and that location. So I want to remind you to utilize the cycle start checklist every time before you hit cycle start. It is a really great thing to help you catch really simple mistakes. I promise it will save you from more than one heartache. There's a reason why pilots use checklists. It is one of the best safety features and tools that we can use. So go ahead and download, print yourself a copy, CNC engrave the sign that we created for the video, and check out the video for the cycle start checklist linked below. Okay, so let's go ahead and go through our list. We know where our emergency stop is. We have homed our CNC machine. We did not totally confirm our material dimensions, but I always like to double check so I know that my workpiece is exactly as I expected. Sometimes I've had it where a client tells me their material is one size. I program it to fit around that and they bring it in. I didn't double check the measurements. So when I engraved the logo on a piece that's already cut to size, it wasn't perfectly centered because it was a ½ inch or an inch longer than I was initially told. So being really sure you know your material dimensions, and no, a lot of these sound simple, but it is going to help you down the line. When we did the jog around with the spindle check, that is also kind of a similar way to make sure that you have it set up correctly. Okay, so preview our toolpath program. So you'll do that in the simulation in your CAD CAM program. Secure work holding, do the little wiggle test to make sure that you have attached your material to the bed as well as you possibly can. Okay, and then we'll go to check router bit installation. I have already installed my router bit, but if you share your machine with other folks or if there's other operators, it's always good to double check that that was tightened down correctly. So we want to verify our work coordinate offset. So did we make sure that we are zeroing to the material surface, or did in our program we zero to the spoil board surface? So always double, triple check those settings, because that's really going to be, I think, the #1 issue that this checklist can really help you navigate, right? Okay, so review Mach4 and G-code. So ensure you have the correct program loaded. Okay, so make sure you load the right G-code program. Sometimes you save multiple versions doing multiple tests, so it's really easy to accidentally forget to load the right program. One tip here is when you're loading your G-code program, so say we're going to load the G-code program for these drawer boxes. So I have a couple of files here. If I organize by date modified, the most recent version of that file goes to the top. So that's one really great way to make sure you're loading the right program. Okay, so test the spindle. So I would say test the spindle and then also run the spindle warm-up program. Those are going to be two things you want to make sure to do. There's a new spindle warm-up program video in the description. Okay, so I'm going to turn the VFD on, put on my safety glasses. VFD is down here. Turn that on. I can hear it turn on, but ensure you know it's on. We'll go to the spindle on-off icon here, and I'll turn it on and then off. Great, so I know that my spindle will turn on. Sometimes it's easy to forget to turn the VFD on. I like to turn it on and off as I am changing bits, just for an extra safety precaution. I recommend you do that as well. And then the last thing is to put your dust shoe on. So I'll go ahead and take my dust shoe and attach that. Perfect, and we want to turn on our dust collection. Okay, let's go ahead and run our program. Okay, great. So our program is done running, so I'm going to turn off my VFD and the dust collector. Great, now our program is done running. I turned off the VFD and the dust collector. So let's go ahead and with our arrow keys, we'll lift up. Lift our spindle up and out of the way and move it back. Excellent. So we have a little bit of sawdust. Let's go ahead and clean that up. So one cool thing is that you can go ahead and test it out before you pull it off the machine. So you can go ahead and put in one of your router bits just to see kind of how it fits. So here I can put my router bit in. I can push it down on the bottom and then lift out far easier than if it was just a flat, straight pocket. I can always put pencils and screws and my wrenches there. Let's try that out. Here's where I can go ahead and just set my wrenches, put some of my extra router bits and that sort of thing. You can customize the tray to fit your exact needs, adding more sections for small bits or large bits, whatever you use the most often. So let's go ahead and actually get this off the bed. So one of my favorite ways to do this to remove composite nails is I use a mallet. My friend John Jaffe made this one. And just tap it on the sides and it will just pop right out. I chose to use the triangular tabs, which I find much easier to cut. There's so many different ways to cut your tabs, and I'm actually working on a top 10 ways to remove and cut CNC tabs. So if you have any of your favorite ways, please let us know in the description or in the chat, and I'd love to consider them for the top 10 video. Okay, I just have this little flush cut saw, which will be a super easy way to do this. Most people have these. It is super affordable and available in most big box stores. Obviously, putting this in a vise will make it a lot easier. Beautiful. From here on, I would just go ahead and get my trim router. throw a little fillet around the edges, clean up my tabs, and just give it a light sand. This bamboo plywood is really smooth, and I'm really happy with the cut quality and the finish. I can't wait to see what versions you make of this tool tray. Thanks y'all for joining, and I'll guess answer some future questions now. Okay, hi everyone. Thanks for tuning in and joining. Let me know if you have any questions about the project, and I'd love to answer them. Let me just answer a few here that Brian's already kind of addressed in the chat here. We will add a link to the 10-step cycle start checklist in the description, and then also in the chat as well. Brian, will you drop that in the chat for me, please? Thank you. Okay. In case you need to use pins or other fixtures, would you model it in as part of your stock? Do you mean if you're going to use pins as alignment or something like that? I do like to model in different parts of my fixtures so that I make sure I won't accidentally cut through them or something like that. It's good to be aware of where your work holding is going to be. So I do think that that's a good idea, especially if you want something to avoid it in machining. Did you design the machine? Yes, so Avid CNC, we design and manufacture all of our own machines. So they're designed in North Bend, Washington, which is about 45 minutes outside of Seattle. It's a really sweet small town. It's where Twin Peaks was filmed, so it's a really sleepy mountain town, and that's where our headquarters are, where all of our electronics are built. We have a machine shop in California where all of our aluminum components are machined. The extrusion comes from various extrusion manufacturers based in the States as well. Yeah, so the Avid CNC machines are assembled and built in North Bend. So yeah, our extrusion is from another supplier, but we do manufacture most of the components ourselves, and then assemble all of the electronics and that sort of thing in-house. We have a really great shop tour, kind of behind the scenes video that gives it was filmed, I think, in 2019. I made that video to show our machine shop and our team working, building different components. So be sure to check that out. I think that's the top video on our main YouTube page. Yeah, good questions. Well, thank you all so much for tuning in. We're going to do the same version of this video, but with VCarve. So if you're a Vectric user or interested in that, be sure to check that out. We have a couple of other live streams scheduled, and I'm excited to keep bringing this to you. If you have any ideas or things you're really interested in learning about, let us know, and we'll certainly add it to the queue, because we're really passionate about trying to bring CNC education and content to our community. So thanks y'all for being here. Where are the spindle motors made? That's a good question. I believe these ones are Hi-Teco, are made in, I think, Italy. So I'm fairly confident on that. Yeah, good question. Awesome. Well, thanks y'all for tuning in, and I will see you next time. Okay. Have a good one, and happy making.